So, what we're doing now in the last 3 weeks we have together is we're branching off of what we were just talking about. It's going to be the same in almost every single way except for how we process our data. Up till now, and I say up till now, over the past couple of weeks, we've been testing single parameters. We've been testing single parameters up till now, yes? And your test, you just did 2 of them. A single value of p, little p, or a single value of little mu. Either a percentage or an average is what you were testing. A single percentage or a single mu. Now some of you are like, wait a minute, well, I don't get how this is a single mu on that test. There were 2 data sets. But what did you do to that data set, those 2 data sets? You took the... On what though, Michael? Yes, thank you. They did a t-test for sure. On what data? How did you process that data to feed it into a t-test? Boom! You did the difference. So technically speaking, if you want to get really fine-toothed combed about it, there are 2 different kinds of t-tests. There's a matched pair t-test, which is what looks, if you will, like you actually have 2 data sets, and you kind of do, but you're not interested in testing the 2 data sets separately. You're interested in testing them together. The difference of them, to see if any one of them has changed from baseline. So they're often called baseline tests. Take a measurement, do something, take a new measurement. Sometimes they're called A-B tests. Some of you guys may have heard this before. Sometimes they're called A-B-A tests. Take a baseline, insert some kind of a experimental factor, take a measurement again, then remove the experimental factor and take a measurement again, and see if they revert back to baseline at that point. Now this can only work with certain things. I mean, if you do permanent damage to something, you can't revert back to baseline. Like if you're crash testing Lamborghini Countachs. Here's one. How's that fender look? Good. Put it in that wall. Okay, bring it back. Oh, you can't do that. So I mean, there's all kinds of, or muscular kind of flexibility could be ABA, but say giving someone a drug that then becomes residual in their system might not be ABA, but they can drug back out of their system. Lyme disease comes to mind. Anybody have Lyme disease in here? I've had it like 4 times. Apparently that's residual in your system forever. So you can't do an ABA on Lyme disease because it's never gone out of your spine. Please, Rosie?
That's a mu, right?
That's a mu.
Okay.
Sorry.
Just slightly
Mu. So you can have a matched pair t-test, which kind of looks like 2 data sets when it, but it really isn't. Then you just have a good old-fashioned t-test on raw data. Over here, you just got a z-test, a one prop. You're according to your TI, a 1 prop z-test. I don't like, in particular, I'm not a huge fan. I'm not a humongous fan of these 2. And the reason, they have their place, they do. But the problem is something that Eric brought up a few weeks ago when you asked me a very, very astute question about a percentage that I gave you in a data sheet. You probably don't remember, it's okay. You asked me, you said, shouldn't that have a margin of error on it? I said, yeah. You remember that? Yeah, I forget which one it was. It was a great question. And every number that you get should have a margin of error on it, clearly. But the thing about the values we're using is they've been replicated for tens of thousands, hundreds of thousands, if not millions of trials, so the margins shrink down to essentially 0. But the math guy in me still doesn't like having these single values we're testing against that seem 70%, right? Who said 70%? Who said 70% is the cutoff? If we make 70% of the antibodies, why are we using that number? Because that's how the CDC defines their vaccines. Why is it 70%? We trust the CDC. We trust them that that 70% is indicative of something. Make sense? Do you remember the multitaskers, the light and heavy media multitasker Stanford study from a couple of homework sets ago? When the quick media conclusion was multitaskers suck at everything they do. So, you see these people like driving on the road and texting on their phone. Oh, I got this. No, you don't. It's been statistically proven that you don't have that. But did anybody question how they define stuff in their experiment? What makes it a light media multitasker, or a heavy media multitasker, or a medium? All those are based on definitions, yeah? And as soon as you define them, then you have a baseline value that you can work off of. But they almost seem kind of artificial to me. 70%, okay, boom. This one doesn't seem artificial, because if the girls gained weight in this study, they're going to be significantly above a 0 change. So 0 is a perfectly logical place to be right there, yes? 0. 0 means the rates are the same on average as they were before. Yes, I like that. That makes me happy. That makes me happy. So these feel like less fictitious to me. And the one we're about to do feels even more or less fictitious. Even less fictitious. Because we're going to get away from single parameters and get into multiple parameters. Yes. And we're going to spend time today, well, we got a little bit more time today. I'm going to start crunching these numbers. I'm going to break the last 3 weeks of the course we have together into 2 or more than 2. So you're going to test 2 parameters at a time, or you're going to test 3 or more parameters at a time. And you're going to see some parallels here between what we've already done and what we're about to do. For example, when you're testing 2 parameters, you can test 2 proportions, call them P1 and P2, or you can test 2 means, call them U1 and U2. We'll get to more than 2 momentarily. When I say momentarily, I mean like Thursday of next week. So a few moments from now. I'm out like we friends call that a minute. See you in a minute. Like October? Cool. So what are we going to be looking at with my bike braking distances? What am I looking at with the bike braking distance, you think? Proportions or averages? We got to vote for average. Eric Blair, we agree with average? Clearly. Laura, because?
Oh, it's measurement?
It's a measurement. Think about Max pointing at a tape. We had a measuring tape down on the ground and he was measuring to which point I stopped. We could make this discrete if I want to see the percentage of time I went over 20 feet, but I want to avoid that because why? Why? Why would I want to not check the number of times I went over 20 feet and look at the percentage for that? Say that again. That would be proportional, and I could test that. But why wouldn't I want to, do you think? Because Dina's going to say, why'd you pick 20 feet? Why not use 19? Why not use 18? Why not use 14? Why not, you see what I'm saying? Why use some arbitrary value like 20, over 20 feet, when you can simply look at the measurements themselves? Yes. Cool? Let's take a look. Let's take a look. Everybody take your data. Let's test Michael's hypothesis. And we'll come back to actually stating these formally in a minute.